Hello, Algebra 1 students, and welcome back to Topic 10, our non-factorable quadratics. Today's lesson, 10.3, is an introduction to the quadratic formula. I'm going to do my best to get all the way through this without any fairly obvious splices or cuts, but I've been a little under the weather the last couple days and my throat hurts, so there might be some times where you hear this awkward jump, and that's just me having paused the video, had some water, and jump right back into it. So, what are we actually doing today? Well, we've spent the last 2 days talking about how we can solve any quadratic equation by completing the square. And in fact, your opener today asks you to solve this equation right here for x. You'll also notice that this equation does not factor, right? This is a non-factorable quadratics, which means if you tried to use the box, right, take a look, don't have to write this because I'm going to erase it, but if you try to use the box here, we would need two numbers that multiply to make 25x squared, and those same two numbers would add to equal this 12x. And I think try as you might, 25 only has a couple factors. 1 times 25, 5 times 5. Neither of those make 12. Non-factorable quadratics. So, what do we need to do? Well, we need to complete the square. And we've learned two methods to do this. Last class, though, we got a nifty formula, and I'll help you get started. You're just going to go with that x squared plus 12x. So it looks like this. You're going to do x squared plus 12x plus a blank. And then, of course, if you add a blank, you better subtract that blank off. Plus 25 equals 0. We also mentioned last class that instead of subtracting, you could add it to the other side. Up to you. There is a slightly faster way to do this too that we learned 2 classes ago. So take a look at your 10.1, 10.2 notes. Your job is to go ahead and solve this quadratic. I've given you a nice first step here, but there are many other steps. You're going to want to write small, or maybe even go into a second column over here, and your goal is to match the answer that's given to you. If you finish that early, please go ahead and try problem 2. Your teacher's going to wander around the room. Once it looks like everyone's done or is hitting a stopping point, we'll unpause and see how you did. Ready, set, go. All right, you're back. Let's look at a couple different ways we could have done this. The way we learned last class involved filling in this blank with a very special number. And I'm going to zoom in here and write the formula up at the top. We said we could take this 12x and we would do half of 12 first. That's like splitting those green x's with algebra tiles. And what is half of 12? Yeah, that's right, it's 6. Half of 12 is 6, and then we'd have to do 6 times itself, which is 36. So to complete the square here, we would add 36. But that throws off balance in the universe, which Thanos does not like. So to be balanced, as all things should be, we need to subtract 36 outside the parentheses. All right, now one question might be asked, what's the point in adding 36 if you're just going to subtract it? Well, adding 36 makes this trinomial right here factor beautifully. We call it a perfect square trinomial. And do you remember the shortcut, x plus? Well, the shortcut involves just making the 12x that's here, right? And to do that, we need to do half of 12. And half of 12 is 6. We also did the same thing up here. X plus 6 squared creates the trinomial x squared plus 12x plus 36. And then we have to combine like terms. Negative 36 plus 25, what's that going to give us? That looks like it's going to be negative 11, I think, equals 0. All right, now what the heck was the point in completing the square again? Well, from a graphing perspective, completing the square lets us see the vertex, negative 6 comma negative 11. But from an equation standpoint, completing the square now allows us to solve the equation with our good old friend, SADMAP. Remember, in the past, the only way we've had to solve an equation with two different x's was using the box. But these are non-factorable quadratics, so the box is not an option. By completing the square, we only have one x left, and so that brings us to SADMAP. I'm going to take the time to remind you what we're doing here. We're not going to use all the letters, just a couple of them today. This 11 is, of course, attached by subtraction. We have the square, which is an exponent. And then we have the 6 where you're like, oh, that's 6, that's addition. It is, but the 6 is trapped inside the parentheses, so we're going to put that here. To solve this equation, we work from the top down, and so we undo subtraction first. The opposite of subtraction is, of course, addition, and I know many of you know this, but it's always good to get an easy reminder to start us off. Okay, x plus 6 squared equals 11. We've taken care of addition and subtraction. There was no multiplication and division. We're on to exponents. Anyone remember how to do a square? Hope you do. To undo a square, we just have to use our square root. Okay. The square root always requires a plus minus to be written in because there's two answers to a square root. But once we're here, the question becomes, what is the square root of 11? Is it a nice number? And you might start multiplying. You might say, well, 2 times 2 is 4. That's not 11. 3 times 3 is 9. That's not 11. 4 times 4 is 16. Oh my gosh, we skipped over 11. Well, that's because the square root of 11 is somewhere between 3 and 4. It's 3 point something something something. It is irrational. There's no nice way to write that answer. And so as we've discussed before, if your square root is not a nice and integer number, then we just leave it in the square root. And that's why in the answer we see a square root of 11. So don't type it into your calculator, or if you did already, that's great, but don't use the decimal. Keep the square root. And you'll see that on the test too. It'll be pretty obvious. Okay, so now we have our x plus 6 equals plus minus the square root of 11. What's left? Well, we need to undo what was in the parentheses. What's in the parentheses? Well, there are no more parentheses, so there's just a positive 6. So we're back up to the top. We're undoing addition with subtraction. We want to make sure that we don't make the second no-no here, and the second no-no would be to say that this is plus minus, what is 11 minus 6? 5? That doesn't work. These are not like terms. That's like x squared and x, not like terms. So if they're not like terms, they just sit right next to each other. Sometimes I get the question, where does that negative 6 go? And the answer is it doesn't matter. You could write it at the end. That's okay. But it is more common to put the nice number, the integer number, out front of the plus minus. And that's it. Now, I did leave you a little extra space in case you wanted a second way to do this, and I'll quickly show that. If you're running short on time, you can totally skip through this part, but this is the way that I complete the square, and so it's always nice, I think, to see a separate way. If the first way seemed too much using a formula, well, the second way to complete the square, x squared plus 12x plus 25 equals 0, is to do a little guess and check, right? This is our guess part, where we said, okay, to complete the square, I'm going to just look at the x squared plus 12x. And to do that, we know it's going to be an x plus 6 squared. Right? We talked a whole bunch about x plus 6 times x plus 6 will get us an x squared plus 12x. And so we're going to look at the check. We're going to say, I hope that's right. I'm going to keep the equals 0 over here too. I'm going to say, I hope that this portion matches that entire thing. Well, as you go through and you make the box, x plus 6, and many of you can already do this in your heads, which is so awesome. It really shows that you're being superstars at algebra, not needing to write this out. Right? This becomes x squared plus 12x. Look at, it's matching everything so good. Plus 36. Ugh, it didn't match. But how do we bring 36 back to 25? You just subtract 11. So to make this guy match what's above, we need an extra minus 11. And then you can take it from there, because this step is the same as this one. So kind of in one step, we did 2 over here. It's up to you. Both ways work. Pick your favorite. All right, now if you haven't tried it yet because you really got stuck on one, you didn't try 2, now you know how to complete the square. That nice reminder, half of b squared to get 36. So try problem 2. We're only going to take about a minute or so on this one, enough for everyone to try one step, and then we're going to unpause, or you're going to come back to this because there's a little bit of a trick to problem 2. Okay, ready, set, go. All right, hopefully you discussed this with a partner and you figured out there's a couple things weird. The first weird thing might be that there is a 4 out front, right? We discussed in the past that we're only going to complete the square in our ax squared plus bx plus c equals 0 when a is 1, right? Up here we had that invisible 1 out front. So how do we solve it when a is not 1? Well, your first guess, hopefully, was we just do the same thing. And that would make sense, right? 4x squared plus 16x plus a blank minus a blank minus 21 equals 0. So we'd have to do half of 16, and that is 8. And then we have to square that 8, and 8 squared gets us 64, minus 64. Great. But then you'd go through and you'd say, okay, well, I think I know how to factor this. I think this factors into, let's take half of 16, that's 8, and it's going to be x plus 8 squared. Well, if you check that using a box, you're actually going to get x squared plus 16x plus 64, and that doesn't match the 4 out front. So then maybe you get clever and you say, ha, there needs to be a 2 out front. Now I'm good. Well, when you check that with a box, you do get the 4x squared, and you even get the 64. But guess what? In the middle, you get 32x. And you're like, well, drat, how do I do it? And the answer is in Algebra 2. Yeah, I know. Not this year or next year. Algebra 2. All right. So how do we get the answer then? Because you are still expected to solve equations when a is not 1 and they're non-factorable in Algebra 1. There has to be a different way. And there is. That's actually the focus of today's class. So, a brief summary. We struggled a bit with problem 2, and that's because the equation fits the form ax squared plus bx plus c, where a is not equal to 1. And we don't know how to complete the square when a doesn't equal 1. So the question that should come up is, how do we solve an equation where a doesn't equal 1? Well, to answer that, we should realize that completing the square is a little bit tedious. There are actually a lot of steps, but they're predictable steps, right? At the very beginning, the very first thing we do is figure out what b is, and then we do half of b and add it on to the end. Every time, half of b, add it to the end. And then you subtract that from the end. And then you write your equation in factored form, where this number is again half of b. And then you undo addition or subtraction, undo multiplication and division, undo an exponent, undo parentheses. Same steps. And like most things in life, if there are repetitive or predictable steps, it is possible to automate or program something that will run those steps for you. When we design a program, we call it a formula. And so what we're about to learn today is the quadratic formula. The quadratic formula needs to take an equation that's in the form of ax squared plus bx plus c, where a can be any number this time, not just 1, and it needs to equal 0. That way the equation is predictable and our formula will work with it. If it's not equal to 0, and we'll see that later on, you just move everything to one side like we've done before. So without further ado, let's introduce the quadratic formula that through a single formula will perfectly solve every equation that's in the form of ax squared plus bx plus c. Now, at first glance, the formula is going to be a little intimidating. I've written the formula here, but with some big blanks in the problem. The reason this formula is so huge is because there are many steps to complete the square, and it's hard to put all those steps in a single small formula. So instead, we have this larger formula, but let's look at a couple pieces of it. There's this plus minus sticking out front, right in front of the square root. And that shouldn't surprise us, because we know that when we solve equations in vertex form, we have to do a square root. That's part of SADMAP, and square root always has a plus minus. There's also a square in here, right? And remember, we had to do half of b and then square it, so that's not a surprise either. Now, a few of these other numbers and negative signs that you see hanging out here are all just part of the formula. We say those are constants. Those are always used in the formula. Okay, and today, when I have you use the formula, I'm going to have you rewrite the whole thing, including the parentheses. Okay? So, let's go ahead and get started. The first thing we need is the actual formula. So the way the formula works is it uses the numbers, the coefficients that are in front of each of the variables. And I almost made a no-no. I forgot to circle the sign as well. So here we go. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. You really need to write this down because this is what the rest of this unit hinges on. You're going to be using this maybe not for every problem, but at least multiple times a day. You should memorize this, and I'm hoping by the time we're done you'll have used it enough times that you have memorized it, but we'll discuss that more as we come to our test. Now, pretty much every teacher has a story or a song about the quadratic formula, right? And so if you have time, look up quadratic formula songs. They're hilarious. We watched our Teach Me How to Factor video too. This one I'm just going to tell you a story. And it's a silly story, but it's the one I'm pretty sure I learned when I was in school, and I've heard other teachers tell before too. And it's just to help you remember the order of the quadratic formula. So here's our story. There once was a very negative boy, and that negative boy couldn't make up his mind whether or not to go to a radical, right, square root, a radical party. He could be square, but if he didn't go, he would miss out on 4 awesome chicks. He decided to go, and then ended up being sad because the party was all over by 2 a.m. And being a teenager, his bedtime wasn't until like 5 a.m. So, negative boy couldn't make up his mind whether or not to go to a radical party. He could be square and miss out on 4 awesome chicks. Luckily, though, the party was all over by 2 a.m. Or unlucky, depending on the person. All right. So, without further ado, let's go ahead and get to actually practicing this. Now, you will definitely need a calculator for today. Hopefully, you're well trained at this point. You already have your calculators out, but if not, you need it because there's a huge step that requires a calculator. So, let's get to it. We are going to solve this monstrosity, 4x squared plus 16x minus 21 equals 0. In fact, haven't we seen this problem before? Oh, right, it was the problem on the first page that I said we couldn't solve with completing the square. Okay, so that was this guy right here. Once my computer finishes loading, right, we didn't know how to solve it completing the square, it just wasn't working out, but we had this answer. Well, we've got the same answer on the second page. So the first thing that we're going to do for each of these problems is we're going to identify the values of A, B, and C. And one of the easiest ways to do that is just to write A, B, and C below each of the numbers. So I'm going to do A in green, and so here is A. A is the 4. Notice I didn't box the x squared. It's just the number in front of x squared. There's no x's in our formula. We solved for x. We took x out of there. We just want numbers in our formula. Then we have B, which I'll do in purple, and B is positive 16. Last but not least, we have C, which I'll do in blue, and C, don't forget the sign, is negative 21. All right, so now what? Well, now we take the formula up above with A, B, and C, and we fill in the numbers for A, B, and C. So it starts with a negative boy, negative B, and so my negative B here is negative positive 16. Plus or minus the square root of B squared, minus 4 times A, which also happens to be 4, times C, and it's very important, negative 21. It's supposed to change to blue, but that's okay. There we go, negative 21. And it was all over by 2 a.m., so 2a, so 2 times 4. All right, and that's it. You have now solved this equation. You've figured out what x is. Or is there more you might have to do? Because if you look at this, x equals negative 16 plus all that, it doesn't really match the answer that we have down here, does it? But there's some parts that match. If you look at those parts, I think we have x here, negative, and then parentheses 16 is just negative 16, plus minus, and then there's 2 times 4, which is 8. It's all over, in this case, 8. But there's something missing, and the missing part is the square root, right? So we have, oops, the computer is struggling today. There we go. We have the square root of something. Well, that something comes from the problem up above, okay? So here is what I'm going to type into my calculator. You can totally do this without your calculator. You just need PEMDAS. However, I found that a calculator makes sure that you don't miss or make any silly mistakes. So what I'd like you to do, please, is type all this into your calculator and see what you get. And honestly, if you did it right, you should get 592. If you didn't do it right, I'll show a couple common mistakes once we come back. But your teacher's going to quickly come around and make sure that you have actually written this down or typed this into your calculator because it's not too hard to type. Okay, ready, set, go. All right, a few notes about calculators. First, hopefully you're not using your cell phone calculator. We want to be using your calculators that display multiple keystrokes at the same time. So here's a quick example of what I mean. I have the old iPhone calculator up here. I know it's not the current one, but it looks somewhat similar. And on this one, if I do 16, and then there's a squared here, squared, it automatically takes me to the next number. And then I do minus 4, and it gets rid of that. I can't see all of my keystrokes at the same time. As opposed to, and I'm going to show you the Desmos Scientific Calculator, that's the one I'd suggest you use on your phone. I think it's the best one out there. When I want to do 16 squared, like so, right, and then minus 4, parentheses 4, okay, parentheses negative 21, you can see everything at once, and I'll zoom in on that, sorry. We can see that that's 592. Plus, if you hit enter, you can see your old history too, which is great. Now, mistakes that you might make on your actual calculator. First, you might have typed everything in correctly, but then this is tough with those blue TI, 30 X2S's, whatever they are. You might have switched around what's a minus versus what's a negative. And on those older calculators, this needs to be the minus button, and this needs to be the negative. On Desmos, though, the button works the same for both. The other thing that I see many students do is they try to include the square root. So they actually do square root, and then they do 16 squared minus 4 times negative 21. And that's not what we want, because we're not using the square root. We're just doing the math inside the square root. So for today, don't touch the square root button, except for the 1 or 2 times at the end of class where you'll have to. Okay, so you've done that. You found that the answer was 592, and then you might be a little mystified because you're like, how is that a useful answer? Well, that actually is an answer. You just have to do a little math on the top, a little math on the bottom, and you get some sort of gross decimal. In fact, because these are non-factorable quadratics, most of the problems we see, not all, but most of the problems today will be gross decimals. And because we don't like to write gross decimals, we just keep them using square roots. Okay, so let's try one more. I want to see the setup for the second problem, and then on your calculator, your teacher is going to be looking for a typed in answer of 8. Ready, set, go. All right, you're back. Hopefully everything went pretty swell here. The most common mistake that I see people make, and I'll zoom back in again, they might get confused by A. A is the 1 that's right here, 4ACL over 2A. And then the biggest mistake is B. They forget the negative on B, and that's going to hurt you in just one place. We need the extra negative here. The negative doesn't hurt inside the square, because whenever you square a number, it becomes positive, negative times a negative. And then C here is pretty nice. It is just 7. Okay. I mentioned you can do this without a calculator too, so I figured I'd walk you through it really quickly. 2 negatives turn into a positive, so we end up with just positive 6 plus minus. We're going to come back to the square root shortly. Notice when I draw my fraction line, though, I make sure the fraction line covers the entire numerator. A lot of students just start doing this, and that's not actually quite correct. Make sure the fraction line goes all the way across. 2 times 1, 2. Okay, to fill in the square root, we just follow PEMDAS, right? We're evaluating something. We're not trying to isolate a variable. We do what's in the parentheses first. There's nothing to do with negative 6, nothing to do with the 1, nothing to do with the 7. Down with parentheses. Exponent next. Negative 6 times itself, well, that's positive 36. Then I didn't give myself enough room. Good thing I can erase here. Minus 4 times A times C. Excellent. And now we're done with the exponent, so we're on to multiplication and division. We know that multiplication and division just works from left to right, doing numbers as we see it. So negative 4 times 1 gets you negative 4 all over 2. We don't distribute with multiplication. Distributive property is a shortcut. Okay, we still have more multiplication though, so let's do the next one. Plus minus 36, negative 4 times 7 is negative 28. And then we finish this off. 6 plus minus 36 minus 28 is 8 over 2. Look at that. So it's worth showing you that you don't need a calculator for this. However, many of you will feel much more confident just going from this first step, typing it into your calculator, and going to the last step. I do encourage you to try some mental math and see if you can get here a little bit quicker. I probably would have just said 36 minus 28 and then made the jump pretty quickly to the answer. But again, calculators are a great tool. Alrighty, we're going to try two more. Don't forget, though, to use that all-important quadratic formula, our equation does need to be in the form of ax squared plus bx plus c equals 0. You might get some weird answers on this problem, but that's okay. Give it a shot anyways. Okay, ready, set, go. All right, hopefully you guys have had time to try, or if everyone seems stuck, let me give you the starting step on each of these problems. This equation does not equal 0. So to make it equal 0, we're going to undo this term. You could undo all three of these and move them over, but that seems like a lot of work. So I'm just going to subtract 4x from each side. Okay, this becomes 4x squared minus 8x plus 4 equals 0. Splendid. Notice on 4, we have a very similar first step, right? There's a negative 1x over here. Gross. We're getting rid of it. My pen took forever to change colors. Also gross. I'm going to add 1x to this side. 0. We end up with 3x squared minus 4x plus 12. So hopefully that gave you guys some help. We definitely needed to start with the correct values of a, b, and c. So go ahead, try again. We'll see how you do. Okay, maybe you guys saw what I meant about weird answers. So let's go through and finish this off. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Gotta love those parentheses. All right, my a value is 4, so let's get that one tackled. 4ac all over by 2am. The b value, negative 8. Negative, boy, catch that double negative. B square, good. And then 4ac, awesome chicks. There we go, lots of 4s. And we're set. Okay, if you do this on your calculator, you'll get 64, and this is also 64. 64 minus 64 will get you 0 over 8. Right? If you went from, whoops, slow to switch. If you went from here to here, you should get 0. If you didn't, double check yourself later. Now, I mentioned this is a weird answer, and the reason it's a weird answer is because we actually know the square root of 0. Or if you don't, you should know the square root of 0 by now. The square root of 0 is just 0. So in this case, I'm actually going to, now that I've simplified the inside, I'm going to use the square root. Because I know when I type in the square root of 0, I don't get a gross number. I know the square root of 0 is 0. And then that's over 8. In fact, because there's no more square roots, I bet I could even simplify this problem to see what the answer or answers are. Let's take a look. I think we're going to get, and we've seen problems like this before with answers. When I wanted to find an actual answer, we just had to make two equations. And I'm going to show you in two different colors here. My first equation is going to use the plus. And it's going to be 8 plus 0 divided by 8. And my second equation is going to use the minus. X equals 8 minus 0 divided by 8. Because that's what a plus minus means, right? There's two answers. And I think we can simplify this. 8 plus 0 is 8. And 8 divided by 8 is 1. All right, if we look at the second one, 8 minus 0 is 8. 8 divided by 8 is also 1. So this is one of those weird problems where we know it's quadratic. There's a square. That fundamental theorem of algebra tells us there's two answers. Our two answers just happen to be the same in this case. But yeah, so if you do know the square root of the number in there, go ahead and take the square root and simplify your answers. Most of the problems we won't know that though. So let's try one more. Let's see if we can figure out why this one is weird. Okay, now if that last problem unlocked something for you and you guys want another attempt before I go through it, feel free to pause me. Otherwise, we're going through it right now. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, and I say this out loud or to myself every time I write the quadratic formula. The more you try to do it from memory, the less you look at the formula up top, the better you're going to do. Okay, a is 3, b is negative 4, and c is 12. So let's rock and roll. Negative, another negative b plus or minus the square root of b squared minus 4ac all over, 4ac, and I'm getting ahead of myself. Now my colors aren't switching. Worst day ever. 4ac, and now they switched. All over 2a. All right, slowing down, letting the computer catch up to my brain, I guess. There we go. All right, and if you type this all into your calculator, the first part you don't need to type in because you know a negative 4 is a positive 4. Hopefully the denominator you're good with 2 times 3. But the numerator, something weird happens. This is 16, and this right here, 12 times 12 is 144. So we end up getting 16 minus 144, right? And if you do that, you're going to get a negative number. And it's okay. I mean, you haven't done anything wrong. Your negative number should be 128. So 128 is in here. Now, this is weird. Does anyone remember why it's weird? Well, it all comes down to the square root. In fact, many of the answers today come down to the square root. So let's go ahead and try the square root of negative 128 on your calculator really quickly. So this time you are actually going to type in that square root. And remember on your calculator, right? On your calculator, you have to hit that second button first, second and then square root, second and then the x squared. On Desmos, I don't, sorry. But I'm just going to do the square root of, we're going to move this out of the way because that always gets in the way, negative 128, and hit enter. And on Desmos, when you do that, you just get undefined. Try it on your calculator. What do you see? You'll probably see one of two answers. You'll either see error or non-real answer, depending on your calculator. Okay, so error or non-real answer. Okay, and so all that means then is that this equation would have no solution. We'll discuss this more in depth next class, but we know that the square root of a negative is undefined. We learn more about those. We call them imaginary numbers. Ooh, in Algebra 2. But yeah, if you get that square root of a negative, don't be surprised if the answer says no solution. All right, let's move on to this next page. This next page is a little bit interesting because you might notice that 5a and 5b are the same problem. And so we're going to do a little bit of a comparison here. We're going to make sure that you remember how to complete the square and how to use the quadratic formula. So you're going to solve this problem twice, once with completing the square and once with the quadratic formula. Now the quadratic formula is a little bit pickier than completing the square because the quadratic formula needs to have your equation equal to 0. And currently 5a is not equal to 0. So I want to make sure, and I'm just going to choose the quadratic formula for this first one because it's what I thought about first. We want to make sure that we have our ax squared plus bx plus c equal to 0 for this guy. But for 5b, if we're completing the square, you don't need to have your equation equal to 0. The only thing that matters is that all of your x's are on one side, and in this case they are. So I'm actually not going to make that one equal to 0. Your goal is to work both equations and prove that the answers are the same. So, good luck. Let's see what you guys get. Ready, set, go. All right. If you got stuck, here's a nice hint, right? The first one, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And our second one, this one's definitely tricky, and I'll give you more than a hint on this and let you try again. We're going to have x squared plus 2x plus a blank minus a blank minus 12 equals 3. Might have to write kind of small in this. There's a few steps. And we have to do half of 2, and half of 2 is 1. And then we have to multiply 1 by itself, which is still 1. So completing the square, the thing that will make this perfect, is just adding 1 and subtracting 1. And don't forget that that factors into x plus half of 2 squared, combining like terms, minus 13 equals 3. So hopefully that gave you a nice start. We should probably give you a, b, and c as well. So there is a, here is b, and don't forget the negative on c, otherwise you'll be getting some imaginary numbers where there aren't some. Okay, try again, finish solving these. Ready, set, go. All right. Did anybody find that the answers are the same? I mean, they have to be. They're the same problem. Okay. Let's finish completing the square first, because now we're down to that SADMAP process, and I think we should be pretty comfortable with SADMAP at this point after having done it for, an awkward amount of time, like 9 months, 8 months, give or take. So we'll start with the addition and subtraction. And as a reminder, if you can, show this in your head, that's totally fine. There's nothing wrong with it. You do not have to go through and show each individual step. Okay, so we end up with 16 and the rest over here. X plus 1 squared equals 16. We took care of the addition and subtraction, no multiplication and division. Oh, there's an exponent. So let's undo the square on both sides. Plus minus. This leaves us with x plus 1 equals, well, actually, I think we should know the square root of 16, shouldn't we? The square root of 16 is actually 4. So I can use the square root of 16, and if I use it, we don't write it anymore, to get 4. Well, that's exciting. Now, I think we just have one number left to undo, and that's the one that's adding, so we'll subtract. But, like we've seen several times before, we can't just do 4 minus 1, because this isn't the number 4. It's both the number 4 and the number negative 4. And so to start, we write the negative 1 on the same side as the plus minus for 4, and then we just make two answers. One answer will be x equals negative 1. Sorry, I should do this in nice color coordination again. So it should be negative 1 with the plus 4. And my other one will be negative 1 with the minus 4. When we finish working this out, we'll get positive 3 and negative 5. Ta-da! That means then that this problem to the left, this square root problem, should get those same answers. So let's make sure it does. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, and our c was that negative 15. Okay. So we get negative 2, there's no extra negative this time, plus minus. This is going to be 4 plus 60. I think this will be 64 if you do it on your calculator. And then we know we're not going to stop here because it has to match this answer, which I think means we probably have to be able to do the square root of 64, which we know, hopefully, or you can use your calculator, is 8. Once we're here, two different answers, just like completing the square. I'll do them in colors as well. X equals negative 2 plus 8 divided by 2. Or, we'll do the other one, negative 2, x equals negative 2 minus 8 divided by 2. Okay, we get 8 minus 2, which is 6. And what is 6 divided by 2? Isn't that positive 3? And doesn't that match our positive 3 over here? What about this guy? Negative 2 minus 8 is negative 10. And negative 10 divided by positive 2, I think, gives us negative 5, which also matches. Woohoo! But wait, is there more? Because looking at the answers for problem 5, we got nice numbers. The technical term for our nice numbers are integers. No gross fractions, no gross decimals especially. And in fact, when you get integers as an answer, that means there was probably a faster way we could have solved this. Do you remember how? Yeah, if you get nice numbers or integers, that means that our equation was actually factorable using the box. Huh. Right, that's what we learned last unit. And we know to use the box, our equation does have to be equal to 0. So let's start off the same way, right? We subtract 3 from each side. And so we end up with x squared plus 2x minus 15 equals 0. And then we use that box method. Okay, so I'm going to do the box method off on the side. And we go through and we say, okay, we're putting in x squared and negative 15. And we're going to need two numbers that add up to equal the number in the middle, the 2x, which will be our extra spaces here. And they have to multiply to equal the diagonal, so negative 15x squared. What are those two numbers? Factoring sheet might help you, but hopefully you got it's 5 and negative 3. 5 minus 3 is 2. 5 times negative 3 is negative 15. Either order. And let's put the numbers on the outside. Now, a was 1, so you might have actually figured out the outsides without this extra step, and that's great. But x, negative 3, positive 5. And so we're not quite done, because negative 3 doesn't match positive 3. This was the last step, the zero product property we learned last unit. We have to write the x minus 3 times the x plus 5. Those are the outsides of our box, right? And they're still an equal 0. To finish this off, zero product property. X minus 3 equals 0, x plus 5 equals 0, and solve. Add your 3 to both sides, At the same time, subtract your 5 from both sides. And we end up with x equals positive 3, x equals negative 5. Right? We always want to keep an eye out for this factoring because almost always factoring using the box is a lot shorter than the quadratic formula, right? Even though the quadratic formula, like I just have to plug it in and get here, well then you have to do the square root and then you have to make two equations and simplify each equation. But I mean, good news, the quadratic formula does work every time. So if this box method has been a problem for you, learn it. However, if you're like, nope, hate it, learn it, and then you can still use the quadratic formula to check your answers. Same thing, completing the square is probably, this year, the least important of the things we do between the quadratic formula and the box, but it turns out to be one of the most powerful, and it pops back up in unexpected places. So learn that too. Just learn everything. That seems easy, right? So let's conclude, easy for me to say, class today, with what causes the quadratic formula to have, quote, nice integer answers. Right? That really means we're going to check to see how we know when to use the box. So what part of the quadratic formula do you all think made the quadratic equation have nice integer answers? Right? If we look back up here, what part out of all of this, or out of all of this right here, caused us to have nice answers instead of gross decimals? And hopefully you focused in on this square root of 64 right here, right? Because when we did something up here, the square root of 592 is a gross number, right? The square root of 8 is a gross number. And I know they're gross numbers for two reasons. First, if you put them into your calculator, you get gross decimals. But second, if you look at that factor sheet, which hopefully you have out by now, you'll notice that especially 8 does not have a box around it, right? Because when we do a square root of a number, it needs to be a perfect square to get a nice answer. So if you're looking at that green sheet and I had said, could you find the square root of 36? And you looked at 36. 36 has a box around it. Yes, you can. So let's backtrack a bit, summarize this, and then put it all together. Here's your fancy word for today. The discriminant is equal to b squared minus 4 times a times c. Where have you seen b squared minus 4 times a times c before? Oh, right. It's in the quadratic formula, right? The big formula thing we've been using all day today. Hopefully you recognize that. It's the part that's under the square root, right? If you have your plus minus square root, this is inside it. Okay? So, with your group, let's go ahead and decide which equations would have nice answers. Okay? By the way, for any with nice integer answers, I'd like you to actually find those answers. I don't care how you find them. If you want to use the box or the quadratic formula or completing the square, but go ahead and find them. Also, this equation is supposed to have an equal 0. That's awkward. But also, we need to make sure that all the equations are actually equal to 0. So for this first problem, you're definitely going to want to add 8 to both sides. And when you do that, you're also hopefully going to realize that the 8 is not a like term with any of those. So it just gives you x squared plus 6x plus 8 equals 0. Now, how are you actually going to start this? I'll start the first one with you. I won't finish it all, but you'll be okay. We're just going to use the discriminant. So the discriminant says we're going to do b squared minus 4 times a times c. And we're going to have to look for something important. Okay, so let's try it. We know at this point, hopefully, that a is 1, okay, b is 6, and c is 8. So let's set this up. Minus 4 times a times c. Okay, b was positive 6. Great. A was 1, and c was positive 8. And you'll realize now that my b's and 6's look very similar. Sorry, I should stop picking problems with 6's. Awkward. But that's a 6. 6 squared is 36. 36 minus, and this is 32, is positive 4. So we would want to either know or think about the square root of 4. Because this is under the square root, isn't it? Okay. Is the square root of 4 a nice and integer answer or a gross answer? That's a nice answer, right? This is a nice I'll put the real term here, integer answer. You can try it on your calculator. The answer is, of course, 2. You can also see on your factor sheet that it is in a box, right, on your factor sheet. And so what that means is we don't actually need the whole quadratic formula here. You could just use your usual actual box, right? You could go through and you could say, I'm not using the quadratic formula. That takes forever. I'm just going to go through, make myself a box, and I know it's x squared, 8, 2 numbers that add to make 6x, 2 numbers that multiply to make 8x squared, and go from there. However, since you've already done the discriminant, using the quadratic formula doesn't take too long either. And you could say, well, I already know the quadratic formula is going to be negative b plus or minus, that's a 6 this time, the square root of 4 over 2a. And you could simplify that down like we did on the previous page. Okay, so it's up to you. But either way, start with the discriminant and see if you decide that they have nice answers. This guy will have nice answers. Once you've done that, once you've decided which are nice, which are not, you're going to go through and you are going to finish solving the ones with the nice answers. Ready, set, go. Okay, so I'm just going to go ahead and set up the discriminant each time just to see if they have nice answers or not, and then we can finish off class. Okay, so we have our 1 here, which is A. Very nice, and it's supposed to show up in blue, but oh well, I'm giving up on it. Then we have negative 10, which is our B, and 4, which is our C. So here's the discriminant, B squared minus 4 times A times C. Negative 10, 4 times A times C. That's 100 minus 16. 100, as I don't have a calculator in front of me, you guys could have typed that all in. 100 minus 16, I think, is 84. If you look on your factor sheet, I think you'll see that 84 is not a perfect square, right? Try the square root of 84. What do you get? You're going to get 9 point something, probably 9.1 something. Not a perfect square, so not nice answers. This is an example of a non-factorable quadratic. You can't use the box. So how can you solve it? Well, you either use or finish the quadratic formula or complete the square. Up to you. Let's try the last one. Sad face. Last one, we know that A is 2, B is a little bit trickier. It's negative 1, and C is negative 3. Okay, so we get B squared minus 4 times A times C. Let's see, B squared is negative 1, 4 times A, which is 2. There we go. It's going to give me 1. This will be plus 8 and 3 is 24. I'm getting 25. And I think 25 is a perfect square, right? The square root of 25 is 5. This does have nice answers, so we could actually use the box here. Totally up to you on how you do it. So go ahead, finish solving those two. I'll give you the answers to them in just a bit. However, I'm not going to give you the work so that way you can impress your teacher with the correct work. If you need help, you can always message me too after the fact, and I'm happy to talk you through it. But it's something you should know how to do. Okay, so ready, set, go. Okay, on problem 3, we'll just start with that one. You should have gotten x equals 3 halves or x equals negative 1. You could have said 1.5. On problem 1, you should have ended up with x equals negative 2 or negative 4. And I used both notations. You should be comfortable with either, but those are the two you should have ended up with. If you didn't get those, please ask your teacher. They can totally walk you through it. Okay, so here's our conclusion for the day. You can use the discriminant or multiple choice answers to equations. That's great for multiple choice tests, like your final you have coming up, to see if you need to use the quadratic formula. If the answers are integers, right, and remember integers are just our nice numbers, 2, negative 5, anything like that, or nice fractions, right? You can still get fractions, that's okay, or nice decimals, 1.5, like above. right? Then use the box method. Factoring's almost always quicker. However, if the answers have roots, think square roots, right? Or you could say really gross decimals, right? Your decimals like, I don't know, 1.4047 whatever, and it just keeps going on forever. Then you'll have to complete the square or use the quadratic formula. So that is all for today. Main part was the quadratic formula. Make sure you're comfortable with that. Bonus part was the discriminant. I'm happy to have you come back tomorrow. We're going to do some more work on the quadratic formula. We'll talk about predicting how many answers it's going to have and also how this helps improve our graphing methods. I'll see you back for 10.4.